Okay, students, now we will be talking about the dimensional constants. Okay, like in class 9, you had learned in gravity a quantity which is called the universal gravitational constant, which is a number. Purely it is a number. There's value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. You had exposed to it. Okay, this is a constant, right? This is a constant, yet it has a unit. Okay, all right. The constant means a number. The constant who has a unit, this comes under the dimension, means it has a dimension. Okay, it has a dimension of force, square of the length, and per square of the mass, right? So this G, universal gravitational constant, is coming under the dimensional constant. The constant who has dimension, but they are a number. This is the dimensional constants. Similarly, you will be learning something called a Planck constant. Okay, Planck constant later. So I'll not write it now. Planck constant, written as H. It is also a constant. However, it have the dimension. Okay, now comes about the last. It is a non-dimensional constant. This is quite important for you, okay, because you need to apply it. Non-dimensional constant. Name itself. It do not have dimension. And it is a number. All right, like for an example, all the numbers. Okay, all the numbers. Okay, let me write it properly. All the numbers, like 1, 2, whatever it is. Do it have unit? No. So what is the dimension? No dimension. Okay, no dimension. So they do not have the dimension. All right, like suppose I have physical quantity 2m. Let m is a mass. Okay, what is the dimension of it? 2. Does it have dimension? No. M, what is the dimension? M. Understood? So 2 is a number. 2 is purely a number. So it do not have dimension. Okay, it is under the dimensionless non-dimensional constant. Similarly, trigonometric functions like your sine theta, cos theta, and all. Okay, because what? Sine 30 degree, what? Does it have dimension? It is what? Half. It's a number after all. Okay, so all the trigonometric functions also do not have dimension, so it also comes under that. Okay, trigonometric functions. Okay, then logarithm function, exponential functions, they comes under this. Okay, so that we will be mainly needing dimensional variables, dimensional constant, non-dimensional constant, and refractive index. Only we had said this is what to say, this is this is a non-dimensional variable. Okay, so I hope it is clear to you. Remember, the non-dimensional constant, they do not have that dimension. Now coming about why are we studying dimension analysis? Because it is useful. Okay, what are the usefulness? Number 1, advantage, usefulness. Okay, this is called the principle of homogeneity, right? Principle of homogeneity. Okay, principle of homogeneity, or means suppose a given relation is there. Okay, like say for an example, v equal to u plus at. I can check whether this equation is correct or not. Okay, whether it is correct or not. See, class 9 we know this equation exists. I know this is correct. All right, but let us check it by using 5-dimensional analysis. Now let's say LHS. LHS is what? V, right? What is the dimension of V? The dimension of V is what? Velocity, isn't it? So this is what? LT to the power minus 1, right? Isn't it? Now coming about RHS. In the RHS there are two terms, right? u. What is the dimension of u? This is what? L t to power minus 1, right? Another RHS. What is the dimension? Dimension at, right? Acceleration is what? L t to power minus 2, and another is t. So this is t. T to power minus 2, t to power 1. This is what? T to power minus 1, L t to power minus 1. So what we have seen that dimension of each term are the same. This means what? This equation is correct. Understood? So I can check by means of dimension analysis whether the equation is correct or not. In the homework, maximum of you have done correctly. Okay. Then in the homework, there was a s equal to ut plus half at square, if I'm not mistaken. Half at square, right? Check it out. S is what? L, right? Ut is what? Can we check ut? Ut is what? L t to power minus 1 t, right? T to power minus 1 t. Minus 1 plus 1, 0. So what is the, this is L only, right? Now coming about another, that is what? Half at square. Let us check it out. This is what? Half, does it have dimension? No, right? A is having dimension. What it is? L t to power minus 2. This is what? T again. T is what? T square, right? Isn't it? Then this is L t to power minus 2, t to power plus 2, minus 2 plus 2, 0. Anything to power 0 is 1. So what is it? So you have seen this also L. So the dimension of S is L, ut is L, half at square is also L. That means what? LHS, RHS, all are same, means what? This equation is correct. So you have done it in your homework. Okay. So the rest of the questions I'm not going to discuss it. Okay. Now another relation, another importance of this is to derive the relation. Okay, to derive the relation. Any relation doesn't mean all the relation. Okay, most of the relations we can derive by means of dimension analysis. Okay, like for an example, this is also there in your homework. I have given you there in your note also, that because it's mostly done, so I'm doing it. Okay, suppose this is a simple pendulum. Simple pendulum is you have seen the wall clock, no? In the wall clock you have seen that bob type of thing. It moves like this. This is a simple pendulum. Okay, in a simple pendulum actually it consists of a thread and a ball. Okay, fine. Okay, then it goes what to say, it goes to and fro motion. Okay, it goes to and fro, goes this way, this way, this way, this way, right? And when it completes one cycle, we call the word called time period. Okay, in case of simple pendulum, okay, we have found that time period, okay, time period depends, I find difficult to write. Okay, depends on, okay, length. Okay, depends on length and acceleration due to gravity, which is written as small g. Okay, so it says they say time period, the to and fro motion of the bob depends on the length of the bob and what to say, acceleration due to gravity. Now in terms of physics, what I can write, time period denoted as t. Depends on means what? Proportional. Length. By what factor? We do not know it. I just write it as x. I do not know what x is. Okay. Depends on length. But why? How factor? Square times or inverse time? What it is? We do not know. Similarly, time factor depends upon what? Acceleration due to gravity. By what factor? Do not know. Alright. Fine. Okay. Now, if we combine these two, we call this equation number 1. Equation, both of them are proportional. So I can combine it. So what we'll get? LXGY, right? Whenever this proportionality, when we have learned with proportionality, dependency, the exactness of dependency, we do not know. So whenever the proportionality is changed by an equal to, a constant should come. A constant is a number only. X, G, Y. Okay, call this equation number 1. All right, fine. All right, now I can have the relation by using the dimension analysis. Okay, the relation is t is equal to 2 pi root over lg. Okay, root over lg. This we will be going to derive by using the dimension analysis. Okay, fine. All right, now if we check the dimension of this, then this is dimension of t is what? T, right? What is the dimension of k? What is the dimension of k? It is a constant, so it do not have any dimension, right? So it do not have dimension, so we don't need to write it. L is what? Length, right? So x is there in the power, so we need to write as it is. Then this is what? L t to power minus 2, and this is y. Okay, fine. All right, now we are going to find out the value of x and y. Then we substitute in equation number 1. Then we'll get the relation. This is the basic idea behind it. Okay, then this t. All right, then okay, L, x is there, and there is y, x plus y. I hope you will understand the steps, right? Minus 2y. Fine. Okay, then if you equate it, this is t, this is t. In between equal to is there. That means the power also have to be the same. So here what is the power is 1, and here what is the power? Minus 2y. What does it means? Y is equal to minus half. We got it, right? And from here, x, this is L. Here is there is L? No. That means what is the power of L? 0. That means no L in the LHS. X plus y is equal to how much? 0. What does it mean? X is equal to plus, in place of y I can write minus half. This equal to 0. This means what?